Okay, so today let's take a look at this LeetCode problem 54 spiral matrix. Given a matrix of n by n elements, m is the rows and n is the columns. Return all elements of the matrix in spiral order. We are given two examples here. Let's copy the two examples. Okay, so in the first example, we are given 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we traverse the matrix in spiral order, then the output is 1, 2, 3, 6, 9, 8, 7, 4, and 5. And in the second example, we are given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we traverse the 2D matrix in spiral order, then the output gonna be 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. So this is how these outputs are calculated. Now we need to design an algorithm that can traverse this traverse any 2D matrix in a spiral order. So how can we do that? Let's say we have such a matrix. Okay, we have such a matrix. Okay, so we start from 0, 0, and then we first traverse the matrix from left to right. And after that, we traverse the matrix from top to bottom. And then we traverse the matrix from right to left. And eventually we traverse the matrix from bottom to top, right? So this is going to be our order. Then we just repeat the process. Repeat the process until all the elements are visited. So now how can we traverse the 2D matrix in this spiral order? The idea here is we have 4 local variables. We call it left, right. Then we have top. We have bottom. So when we traverse the matrix, we keep updating these 4 parameters to indicate the boundary. Like for example, after we traverse all the elements on the first row here, what we're gonna do is we're gonna increase the top value by 1 to indicate all the elements on the first row has been visited, right? And then when we do the top to bottom traverse, we start from the next row. And also similarly, after we traverse from the top to bottom, then we decrease the right by 1, right? After decreasing the right by 1, when we do traverse from right to left, we start from this position, right? So we just keep doing this, and when we finish traversing on from right to left, we're gonna decrease the bottom, right? Decrease the bottom by 1 before we do traverse from bottom to top. So we just keep doing this until all the elements are visited. Now let's code it. So we need to check some corner case. Let's do that first. So we just return the empty list if the metric is null or has length 0. And then we have two variables. And we have top, we have bottom. Right? Then we just traverse. So the idea is we traverse the matrix from the edges towards the entry, and when we need to break the loop, so even when the top equals to bottom, we still need to traverse, right? And similarly, if left equals to right, we also need to traverse. So yeah, so I think this is right. So now let's first traverse from left to right. We should start from left. So we should keep checking this left smaller or equal to right, as well as top is smaller or equal to bottom. And then we do I++. So when we traverse from left to right, what doesn't change is the row index, right? So the row gonna be top, and the column index will be I. After this, we're gonna, what we should do? We should increase the top by 1. And then we do traverse from top to bottom. So what doesn't change is the x index. Sorry, y index. X row index gonna be changed all the time. Yeah. This will be right. And after we finish this one, we decrease right by 1. And then we traverse from right to left. So what doesn't change is the row index, which is the bottom. And after we finish the traverse from right to left, the bottom will be decreased by 1. The last step is from bottom to top. What doesn't change is the column index, which is left. Okay, and when we do this, we increase the left by 1. Then we just need to return the result. Okay, let's submit it. Okay, so let's take a look at the time complexity. So very simple, right? So we basically visit every element in the matrix. So since this is m by n, is m by n, yes. So the time complexity will be big O n by n. And also regarding the space complexity, since we used a list to store the data, so yeah, the space complexity will be the same as the time complexity, which is big O m by n. Yep, that's it.